Hi. So while we are going to continue with examples on finding derivatives, I just want to make a clarification from a question that I got previously, where someone said, if you're saying f of x is equal to f of x and g of x, why are you then, when you're finding derivative, only representing the function with x as opposed to the other two? And the question is legit. So representation here is not what matters. We know that the big F function, function f, big F, up here, is actually a function of f into x, small f, and g into x. So if you wanted to add more clarity to it, you would rather represent this big F function as f of f into x and g into x, right? That's how you would represent it, is equal to f x g into x, which means that this big F is a function of these two little functions right here. So when I say f of uv is equal to uv, then I would say f prime of uv is equal to v du plus u dv. So derivative of the function with respect to u plus the derivative of the function with respect to v. So this is the same thing we did, except that instead of having here uv, we were just saying f of x. So this f of x is a completely different function than this f of x. So just make note of that, and don't be confused by it. I hope that this clarification does make sense, and that now you know what I'm referring to when I say big F of x is equal to something. So I will move on to essentially our topic for right now, which is going to be more about looking at so we'll go straight to quotient rule. So you know how the above here was f of uv is equal to uv. Suppose f of uv is equal to u over v. How would you get the derivative of that? So in that particular case, f prime of uv what we do here is that you get u. Actually, I'll have it the other way around. It doesn't really matter, but I have it the other way around. So I'll have v du minus u dv over v squared. So that's what you use for finding derivatives of fractions, essentially of functions. So I'll go straight to example 1. Find the derivative of f into xy is equal to x cubed over y squared. How would you find that? So in this particular case, f prime of xy is given by, in this particular case, I guess, what is our uv? Right? What is our u? So u is equal to x cubed, v is equal to y squared, essentially. So going back to this formula right here, I'll put my v here as y squared, differentiate the function with respect to u. So u we said is x cubed, so times 3x squared when you differentiate it, minus, what is u now? X cubed times derivative with respect to v, which would be now 2y. If you don't remember how to do the derivatives of those, please go back to some of my previous videos and they will explain exactly what we're doing. So divide by v squared, and we said our v is y squared, so this is going to be y squared squared. So this is going to give you essentially 3y squared x squared minus 2y x cubed over y to the 4. Now you can simplify this further and cancel out one y, so that y and that with 1 there. So this, your final answer would be 3y x squared minus 2x cubed over y cubed as your final answer for the derivative of f of x of y. So that is how you do the quotient rule. I want to give another example. So example 2. Example 2. So in this particular case, we will use trigonometry. So I will say, find the derivative of the function tan of x. So you will say, well, tan of x, I could just take it as it is and get the derivative of that. But in our case, we're trying to show, to use the quotient rule. So I'm going to change out our tan of x into something that looks more like a fraction so we can apply our quotient rule. How do I do that? Tan of x is the same thing as sine of x divided by cosine of x, right? So now applying, remember where we said again in the previous example, we said f of u of v is equal to u of v, f prime of u of v is equal to v du minus u dv over v squared. It's the same thing we're going to do here. So what's your u, what's your v? So in this particular case, sine is your u and cosine is your v, right? So the derivative dx of tan of x is given by, what is your v, which is cosine of x, times the derivative of u, which is cosine of x, minus u, right, which is sine of x, times the derivative of cosine of x, which is v, so which gives you minus sine of x, divided by v squared, which is cosine of x squared. This is going to give you something of the sort. So this is going to give you cosine squared of x plus sine squared of x over cosine of x squared. So what does this give you? Remember that cosine of x squared plus sine of x squared gives you 1. So which means d dx of tan of x is equal to 1 over cos squared x. So you could end here, or you could proceed and say that what is the sign, what is this equal to? So this means 1 over what's the derivative? Sorry, what's 1 over sine? 1 over sine is equal to what? Secant. 1 over cos is equal to what? So I will I'll leave this one here as 1 over sec squared. Sorry, not 1 over. As sec squared of x.